Hello everyone, today I'm going to perform the lecture on soil compaction. So before I'm giving the lecture on compaction, let's see the some formula. Here is here's a graph. X-axis is optimum moisture content, Y is a dry density, and the formula is dry density gamma d max equal to Y divided by volume Y, or gamma moist divided by 1 plus moisture content. So this formula we'll use. So we'll see after when we'll perform the math. Optimum moisture content is omega, and 0 where void is gamma w gamma plus 1 plus gs, and gamma w will find out unit weight of water and moisture content is varying 5%, 10% and 15%, and specific gravity of soil 1 2.6, and relative density will see the gamma field divided by gamma moist or lab into 100, and compaction between field and frequent field compaction r equal to r naught 1 minus d r 1 minus r naught, or gamma d minimum divided by gamma max. And relative density will use this formula gamma relative density dr equal to gamma field minus gamma minimum gamma maximum minus gamma minimum gamma maximum minus gamma field, or E maximum minus E maximum minus E equal to E means is a Boyer ratio, and we will find delta sigma equal to Q into I, Q equal to P by A, and Q equal to we can find unit A into unit weight, M equal to B by Z. So the small portion is B and vertical depth is Z. L equal to N by Z. L equal to length, bigger length, Z equal to vertical length, and we'll find the I value from chart. Okay, let's see. So this is our soil compaction. So we know the soil must be compact in case the unit weight. Okay. In the construction of highway embankment, earth dam, and other engineering structure, loose soil must be compacted in case with the cell. So here is a between concentration and compaction. Concentration means water will be spread out, or water will be come out from saturated clay, and compaction means air will be come out from partially saturated sand. So this is the difference between concentration and compaction. So so we can see the concentration is and we'll construct a building, and then and dry moist situation. Compaction will be used when we construct the road. Okay. The general compaction general principle. The compaction is the define of soil by removing air. So this is the compaction, removing by soil, which is required to mechanical energy. Okay. So we can see here moisture content increase in x-axis, y-axis is unit weight of moisture unit weight, moisture unit weight, and this is the moisture content, and we can see the here this portion is soil solid, and this is water, and this is also solid soil. Okay, when the moisture content is gradually increased, and the same captive effort is used to compression and the weight of soil solid in unit weight gradually increase. For example, W equal to W1 and Y equal to 1. Okay. Is the modified Buckford test. This is another factor affecting compaction. Effect of the soil type, you can see here the graph. Axis is the moisture content, which is 5, 10%, 15%, and 20%, and dry unit weight is y-axis. So when the moisture content is, and we can see that the first graph is sandy silt, then the silt clay, and the clay. So you can see when the moisture content is increased, then the graph is also going to the right side, which is clay. Okay. So types of component curve, you can see A, B, C, T, and A is a bell shape, and between is the liquid limit, where 30 to 70 there is a bell shape when the liquid limit is 30 to 40 and half, 1.5 peak less than 30 when the liquid limit is less than 30. This graph will be appeared. Double peak less than 30, and those generate greater than 70. So if the greater than 70, this will be double peak. And old shape, when the greater than 70, the liquid limit is 70, then that will be old shape. Okay. The effect of compaction, we know the number of blow per layer and number of layer and weight of the hammer and weight of the deep hammer divided by volume of mold. So you can see here E is a 59 kilonewton meter per meter cube, or 600 kilonewton meter per meter cube. Okay, so this graph is important. We can see here the axis is the moisture content, y is the dry unit weight. So this blow is we can if we zoom here, so the 50 blows of the layer here, and 30 blows, and 25 blows, and 20 blows. So these are the decreasing, and this line is, you can see the zero air void curve, which is specific gravity 2.7. We can find out the zero air void from this formula, gamma w divided by moisture content plus 1 plus gs specific gravity. Okay. So zero air void means air will be filled by water. This is called zero air void. Okay. Modify Proctor test. Here is some method summary of the standard and modify compact test specification. The mold volume, we know 944 cubic meters, so we have to memorize it. And diameter 1.010, and the standard Proctor test, we have been seen here the number of blows per layer 25. On the other hand, modify Proctor test was also number of blows 25. But difference between the weight of standard Proctor test, the hammer weight is 24.4. On the other hand, we can see modify Proctor test in 44.5. The height of drop is 305 millimeter. On the other hand, the modify Proctor test the height of drop 457. So number of soil layer is 3. We can see here another number of 5. So this is our last math example. So let's see the math example. In the laboratory test result of the standard Proctor test. Here the standard Proctor test are given in following table. Table is given, but I have been told you the volume of mold 944 cubic meter will be not given in example when we see the standard Proctor test, because we have been seen here the standard Proctor test and modify Proctor test. The volume of small is constant, 944 cubic meter. Okay, let's see. So another is unit weight of soil. Here is a tableau. Is mold is given is Newton 16.8117, and moisture content is given 10%, 12%. So we have to determine the maximum dry unit weight, gamma d of the compaction, and the optimum moisture content. So we have to find out the maximum dry unit weight and optimum moisture content. And second, we have to calculate and plot gamma d versus moisture content for saturated 80%, 90%, and 100%. Okay, let's see. So we can see the volume of mold is given here. So we are putting this value 944 centimeter cube, but we have to memorize it for standard proctor test. The volume is constant, and weight of soil is given also here. Weight of soil is here 16.81. So here, okay, 16.81. Now we will calculate the moist unit weight. So gamma moist equal to W divided by volume. W mean weight. So it is given 61.81 divided by volume 944. So we will find the 17.81. Consequently, we found 18.90 and 19.50, 19.42 and 18.30. So moisture content is given here. So we are dragging here the value here. 10%, 12%, 14% is given here, and last one is 20%. So we will calculate the dry unit weight gamma d equal to gamma 1 plus moisture content. So if we go to the this formula sheet, we have been seen here the dry unit weight equal to W into B equal to gamma moist divided by 1 plus unit moisture unit weight. Okay, moisture content 1 plus moisture content. Okay, let's see. Then putting this calculation and found gamma, we have been here 17.81 divided by 1 plus moisture content 10 plus 100, and found 16.19, and second one 16.87, and third 17.11, 16.47, and consequently 15.31. Now we'll draw this graph. Axis is the moisture content is given here. Moisture content 10, 12, 14, and up to 20. So we have been 10, 12, 14, and up to 20. And we have been found dry density. Here the dry density is 16, 16.5, 70, 16.5. So here is the dry density 16, 16.5, 70, 70. So from this point we have been found the maximum peak value is here. So after changing color, here is the maximum peak value. So the maximum dry density we have been found 17.11. So we will find after this position we will find the maximum moisture content. So maximum dry density we have found 17.15. We have been from this curve, and consequently the position optimum moisture content I have found 14.4% from this curve. Okay, so this one is completed. Second one would calculate the and plot gamma d versus moisture content. So let's see. Okay, so there is a three type of saturation: 18%, 19%, and 100%. So we have been seen the GS is given and moisture content is also given, and this is for 80%, and gamma d is, we know this formula we have been used, GS gamma W 1 plus GS gamma S and S. So GS is 2.7, here is a 2.7 and 9.81, and 1 plus specific gravity is given also here. lost. Sorry for interrupt. I have lost the page. Okay, so we have been seeing here the various type of when the saturated is 80% and found this value, and when the saturated is 80% and found this value, and when the saturated point is 100% and found this value. So we have been drawing this curve. Compared to x-axis is moisture content and y-axis is gamma dry humid weight, and this graph will be found three type of graph. Okay, so let's see another example. Here is we can see another example is given here. The difference of maximum and minimum void ratio is 30 is given, and if the relative density is 66.66 and at void ratio 4, what will be the saturated density of soil? Example. So dry density we know here from this formula sheet is given the dry. This is the formula, and dry equal to max minus E divided by max minus E minimum, and found the maximum is 6.66. So, and another one we can see saturated equal to GS plus E max 1 plus E max divided by into gamma W, and found 19.92. Given this value, and we have found the saturated density of soil. Okay, this is from the relative density, so you have to memorize that. From calculating relative density, we have found the void ratio, and then putting this value void ratio, and found the saturated humid weight. Okay, so let's see another example. Here the soil having 6 feet depth, and its relative density is 40% with the maximum void ratio is 0.46, and maximum void ratio is given also 90.90, and it is the specific gravity is 2.65. Find the dry unit, find the dry density of soil. Okay, so this is the given all the data. H equal to 6 feet and dry set is equal to 40%, and E max equal to 0.45, and E max equal to 0.90. Specific gravity is given 2.6. So we are putting all the formula here. Dry density E max minus E max minus E. So we putting E, and we have found the void ratio E equal to 0.724. After finding the E, now we'll put this value gamma D equal to GS equal to gamma W1 plus E, and putting all this value, and found the unit weight of soil is 95.92 pound per feet. So this is the lecture will be in depth from compaction. If you have any question, then let me know. Thank you everyone. Thank you. This is the formula sheet. Okay.